Okay, let's go to page 131, and this is section 11.5, and this is about congruent triangles. Okay, congruent triangles means that two triangles are exactly alike. Okay, it can be rotated, it can be flipped over, but when the congruent means all three corresponding angles are congruent, and all three corresponding sides are congruent. Now, in order to prove that two triangles are congruent, you need to have three congruents. Okay, and so the first one is called a SSS, means a side side side. Okay, so that's example illustrated by this. So if this side is congruent to this side is congruent to this side is congruent to this side. If that's the case, and that means the two triangles are congruent. That means if you slide this over on top of each other, it would be exactly matched. Okay, so it can but it can be flipped over, it can be rotated, but as long as the corresponding side are congruent, then they are congruent. Okay, so this is called SSS, side side side. Another way to prove that triangles are congruent is the side angle side, so SAS. Notice the angle had to be between the two sides. Okay, so that's SAS. Okay. Again, notice the triangle can be flipped over, it can be rotated. Okay, but as long as you have the side angle side, and again the angle must be between the two sides. Okay, so again these two triangles are congruent. Okay, so now it gives you a warning right over here. So like these two over here, again, if you notice the angle are not between the two sides, so these two are not congruent. Okay, so that's not SSA. Okay. The next one is on the very bottom. Okay, it's right over here. So another way is the ASA. So you can notice the size between two angles. So when you have three letters, notice the one that's different had to be in between the two. So the side had to be between the two angles. Okay. And another one is the AAS. The AAS is kind of derived from the ASA, because over here, if the two angles are congruent, then the third angle must be also congruent. Okay. So again, if these two angles are congruent to these two, that means the third one had to be congruent to each other, and so because these two are congruent, therefore you got SAS. Right. So again, this is kind of the deviation from the ASA. Okay. Now, when you have a right triangle, then it gets a little bit easier. Once you have a right triangle, then any two corresponding parts are congruent, and they are congruent. Okay, so you got HL, the hypotenuse and the leg. Okay, the reason all you need is two letters is because the angle is already congruent already. Okay, so that takes care of one of it. Notice all these are three letters, but for right triangle, the angle is already congruent already. So all you need is two more congruents, and so this is HL, LL. Okay, and then you have the SA. So SA is the side, one side and one angle. And again, if the one angles are congruent, and this is already congruent, so it means the third angle also has to be congruent. And again, this is a deviation of the ASA. Okay. And then, so you actually there are more than these. Okay, but these are the more common ones. Okay. Okay, now when you're doing a congruence, you got to be very careful. Make sure you match things up carefully, like this one over here. Okay, so let's go and do this example 11-9. Now, whenever I do this, I normally like to draw a different picture so I can kind of match things up. So I'm going to separate the two triangles. Okay, so this is A, and this is 60 degrees, this is 70 degrees, and this is C, B, D. Okay? Okay. Now notice it tells you that triangle ABC is congruent to triangle BAD. Okay? So for this triangle, notice angle A, you have to match it. Notice the angle A matches with angle B. So that means this is 70, this would be 70. Okay? So again, the angle A from here, the A on here match with B over here. Okay? So when you're doing the congruence, you have to match the letters carefully. Okay? And over here, so the angle B from here will match the angle A over here. So that means this B, the angle B from here will match with angle A on the second one. So this would be 60. Okay? And the C over here will match up with D. So by using your geometry, the three angles equal to 180. So this would be 50, right? 180 minus 60 minus 70 give you 50. Therefore, this would be a 50 degrees. Okay? And so in this case, they actually found angle D. So angle D will equal to 50 degrees. And that's it. Okay, let's go and do example 11-10. It says prove if two angles of triangles are equal, then the sides opposite those angles are equal. Okay. So if two angles of a triangles are equal, then their opposite sides are equal. Okay. So the way you're going to do that is you draw down a perpendicular line over here. Okay. And they label A, B, C, X. So you draw AX, which is perpendicular. Okay. And so again, the giving. So remember, you cannot remember a little bit from your geometry proof, right? So your giving is angle B is congruent to angle C, right? So you draw AX and it's perpendicular, right? So you can see that the AX is congruent to AX, and this is reflexive, okay? Now normally you put a reason in the back. So this is giving, okay, and this is reflexive, okay, because they're equal to each other. Okay, so you put a mark over here. Now because this is the right, so since this is the right triangle, and so then you can see that triangle AXB is going to be congruent to triangle AXC. And the reason for that is because you have the LA, right? Or the side A, SA. Okay, the reason for that. So this is the reasoning. Okay? Okay, now since the two trunks are congruent, then AB is going to be congruent to AC. Okay, and that is called the CPCTC. Corresponding parts of congruent triangles are congruent. Okay, and so that's it. So you can see that this has to be congruent to that. So the sides that are facing the congruent angles are congruent. Okay.